Hello programmers! Today we're going to talk about the data types that are available in C++ and how you can make your own data type. So anything that was available in C, like the short, the int, the long, those are all available in C++. And I've got these listed from smallest to largest. We have also unsigned versions of these data types. If you know you're not going to have a negative number, you can give yourself more bits to work with if you use an unsigned short, unsigned int, unsigned long, or unsigned long. We also have floating point data types. If you have a decimal point in your number, like 3.14, then you could use a long double, a double, or a float. Let me show you how I can figure out exactly how big each of these are on my computer. So I've just got a bunch of cout statements to print to the screen the string long double size is, and then I'm going to call a function size of and say what's the size of a long double, what's the size of a double, a float, a long, etc. And then I can run this and see that on my computer here are the sizes of all of those data types. So I've got them from largest to smallest here. Well, what happens if you're doing some math and there's more than one data type involved? Let me show you an example. So what if we've got two variables? I'll start with x that's set to 7 and y that's set to 2. Well, if I want to do division and I want to say what is x divided by y, well, you can probably do that answer in your head, but you may be surprised when you run this and we see that according to the computer, the answer isn't what we think it is. We think it's 3.5, but according to this program, the answer is just 3. So notice it's not even rounding up, it's just truncating. So if you've got an integer divided by another integer, and this should have been y, but they're both integers, we've got an integer divided by another integer, well, it wants the answer to be an integer. So that's why we ended up truncating. How do we change this so we're not truncating? Well, one way we could change it is just if we were using one of them as a floating point number, then it wouldn't truncate. We could also cast one of the existing variables that are ints and cast it to something like a float, and then it will keep that decimal point around. And I'll go ahead and run this. So a floating point number has more precision than an int. You can have a decimal place, and so the unifying type, the type it's going to pick when it has int divided by float, is the float, and we'll get that 3.4. What I just did there was called an explicit cast by casting an integer to a float. That's the C way of doing it. There's another way to do it in C++, is you can do the cast this way, and we're going to get the same answer. Well, what about, I said that was an explicit cast, so that kind of implies that there is an implicit cast. What's an implicit cast? Well, if I say I want a double, and we'll say the double variable name is z, and it's going to be x plus y. Well, x and y are both integers, so when we do the addition, normally we're going to get an integer, but here, because we're saying we want a double, it's going to end up kind of promoting that integer and switching it into a double. And how do I verify that it really is a double? Well, I'm going to put a print statement where I print not only z, but the size of z. And if I look back to the size of those different variables, the size of a double is actually 8 bytes, and the size of an int is 4 bytes. So when I run this, I see that I've got my addition, 7 plus 2 is 9, and the size of that variable is 8 bytes. So we can tell that it is now a double, even though we were just adding 2 integers. So that was an implicit cast. The system just did it on its own because it's the right thing to do. What if the built-in data types are not enough for our needs? So we want something a little more complicated than an integer or double or a character. You can create your own data types in both C and C++ by using structures. So in C++, we can say we want a brand new data type called course, and every course involves a number of credit hours. And I try to make my courses fun, so I'm going to also have a fun meter for my course. In main, if I want to create an instance or allocate some memory for a course, then I'll just put course, the data type, and then a variable name. CS225 is one of the courses I'm teaching now. So I could say I want to set the number of credit hours for that course, using the dot operator and then the name of that field. So the names of the fields are credits or fund meter. We can set them by having the name of the variable that's of type course and then a dot operator. So let's set the fund meter. So I would hope that all my courses are super fun. So I'm going to put 100 on the fund meter. And we can also print out what is inside of any of those fields inside of my object with the dot operator as well. So I can set them or I can print them. So structures are one way to create your own brand new data type in C and C++, and we have one other way to do that, and that is using classes. And so if we were to change the structure to a class, it would look something like that. And to create an instance of that class, we're going to create an instance the same way we did with structures by having the name of the data type, the class, and then a variable name. And you might notice that I quickly deleted some things under there. There's a difference with structures and classes in what main is allowed to directly access, and I wanted to avoid a compile error. More on that later, but the way to create your own brand new data types in C++ is either to create a class or to use a structure.